Hey guys, welcome back in. Mr. Marone here. We are in section 10.5. We are in inscribed angles, which are a little bit of a different setup than we're used to. We've been dealing solely with what are called central angles, or angles that have their vertex at the center of the circle. So now it's a little bit of a different change up. So an inscribed angle is an angle whose vertex sits on the circle. And an example of that would be angle ACB in this picture. So A out to C and then up to B. And we have this new concept called an intercepted arc. I've maybe referenced it in previous videos, but in this case, an intercepted arc is the section that's the part of the circle or the arc between the between the inscribed angle. So the part that's contained within the angle is the intercepted arc. Okay. Now, if you notice, I'm going to put it in green, we also have this central angle here, AQB. And up until now, we've said that AQB, whatever the measure is, in this case x, that the arc it intercepted was going to have the same measure. When we deal with inscribed angles, though, it's a little bit different. An inscribed angle is going to have, the measure is going to be half the intercepted arc. So the inscribed angle, and that equals half the intercepted arc. So if my arc here was 60 degrees, my central angle would be 60 degrees, but my inscribed angle would be half of that and would be 30 degrees. So it's this half-double relationship. If I have an inscribed angle at 30 degrees, the intercepted arc is going to be double that and be 60 degrees. And we're going to do a bunch of examples now so that you get the feel of it here. So in this first one, they gave us circle P and angle S is the inscribed angle. They told me that RT is 47 degrees. Well, in order to get the inscribed angle, we have to do half of 47. And half of 47 is going to give me 23.5 degrees. So angle S is going to equal 23.5 degrees. I literally just cut it in half. So if you look closely here, in example 2, they said DG was 45.6 degrees. And they want to know what are angle E and angle F. Well, angle E is an inscribed angle, and it intercepts 45.6. So I'm just going to cut it in half. Angle E is going to equal half of 45.6. And I end up with 22.8 degrees there. To get angle F is inscribed, sits on the circle, and it intercepts that same arc. So it's going to be half of 45.6 degrees, which will also be 22.8 degrees. So this showcases that if I've got two inscribed angles that intercept the same arc, their measures are going to be the same. So in the future, you can do the math for one and then just use it for the other. In example 3, they tell us that RT is a semicircle, which means it is a 180 degree measure. They want to know what's the measure of RST, or that inscribed angle. Well, angle RST is going to equal half of 180, which you guys already, I'm sure, have seen, is going to be 90 degrees. So whenever you've got a semicircle, the inscribed angle is always going to equal 90 degrees. It's always going to be a right angle. In example 4, I'm going to let you guys try this one and see how you do. So here they told us that ABC, so from here all the way around to there, is 184. And they told me that BCD, from here all the way around to here, is 242. They want to know what are the measures of the angles of the quadrilateral here. So they want to know what are all of those angle measures that are in there. Go ahead and take a look at that and see what you come up with. And when you come back in, I'll have all the angles listed out for you. All right, welcome back in. So if we look closely at this, if I take out that arc right there, and if we just look at this, from B through C to D is actually the intercepted portion of angle A. So if I take half of 242, I get 121. Now, if we look very closely, I'm going to put it in red so we see it separately. What's left is arc BD, which is actually the intercepted arc around angle C. So all we have to do is take 121 and subtract from 180, and I've got the remainder of the circle. If we did 360 and we subtracted 242, the only thing that's left is 118 degrees for this arc right here. And when I cut that in half, I do get 59 degrees. And we're going to do the same process for my other arc. They gave me that arc ABC right here, which is the intercepted arc of angle D. They told me that was 184. So when I cut that in half, I get 92. And that leaves only this portion here, ADC, which if we do 360 minus 184, we get 176, and that is angle B's intercepted arc. So we cut that in half, and we get 88 as our final answer. So it takes a little bit of thinking, a little bit of looking, but overall some very simple arithmetic to solve. So the last one I want to show you guys, or last two, are right here. Here they asked us to solve for x and then find the measures. So if we look closely, we've been given an inscribed angle, and we've been given its intercepted arc. And we know that angle F, the inscribed angle, is half the intercepted arc, so half of EG. All I'm going to do is plug in those values. So I'm going to have 8x plus 10 equals half of 12x plus 40. At this point, you really have two options. If they give you all even numbers in here, just cut them in half. We want small numbers if we can get away with it. If they're odd numbers, we can multiply both sides by 2 to get rid of that fraction if you don't want to deal with fractions. I tend to deal with fractions if they're even numbers, and I tend to multiply by 2 if they're odd numbers. So since these are even, half of 12 is 6x, half of 40 is 20, and now I've just got 8x plus 10 equals 6x plus 20. And I'm going to move some stuff around, and I end up with 2x on the left, and I end up with 10 on the right, and x is going to give me 5. They then want us to find the measures. So 5 times 8 plus 10 is 40 plus 10. So my angle is 50. Angle F is 50. So that tells me right away that EG's measure is going to be double that, or 100. All right. Go ahead and answer the last question here. They tell us that x's value is 55 and that y's value is 40. And they want to know, is CD a diameter of the circle? Go ahead and try that, and when you come back in, you'll have the answer. Okay, welcome back in. So if I add up the two angles they gave me, I got 95 degrees. Subtracting from 180, that tells me angle B's measure is 85. In order for us to have a diameter here, that would make this a semicircle. This would have to equal 180 degrees to make that angle equal 90. Since angle B does not equal 90, no, this is not a diameter of my circle. So through all of these, there's all sorts of ways these can go. It comes down to one rule right here, that your angle is half the measure of the intercepted arc. Don't lose sight of that as you work through these problems. If you have any questions, bring them into class tomorrow. And other than that, have a great night. Bye, guys.